lot of chance this afternoon to welcome not someone else, but very important Harry Seah. Harry Seah is very important, and I will just go through his biography in order to understand. Harry Seah began his career in then the Ministry of the Environment, managing solid waste management and disposal, and sewer design and maintenance before he was appointed as the project manager for the new water demonstration plant study, and later he oversees engineering development and procurement departments in development projects on desalination, new water, and WRPs and waterworks, as well as the deep tunnel sewerage system departments on meeting Singapore long-term needs for used water collection, treatment, and disposal. Harry was appointed to his current position in January 2016 to provide strategic and integrated oversight to the development of new technologies, innovation, and engineering competence to support PUB. For the newcomers, PUB means Public Utilities Board, waters, infrastructures, and operations. It provides strategic and integrated oversight to the development of new technologies, innovation, and engineering competence to support PUB, waters, infrastructures, and operation. He oversees as well development projects such as the deep tunnel sewerage system. And it's important also to mention that Harry chairs the NTU, National Technology University of Singapore, Environmental Engineering Program Advisory Committee, and is a member of the governing board of Singapore Center on Environmental Life Science. And Harry is also member of Scientific Advisory Board of Emerald Green Venture, a Swiss venture capitalist firm. Thank you very much to be with us this afternoon, and the floor is yours. Thank you very much, Harry.
Okay, good afternoon, everyone. Prof. Bevi asked me to give a bit of my personal journey. Okay, actually my ambition was actually to be a structural engineer. So I did, during my undergraduate days, everything structure, right? Because I want, in a way, to tell my children that, hey, your daddy did this building, did that building. But maybe the danger of having a scholarship in Singapore is that you can be signed anywhere to any places. So the first posting that I had was in solid waste management. And to my horror, it was never covered in my undergraduate. So I have to start from scratch. Imagine managing the whole solid waste or garbage treatment, cannot afford a failure in collection because that will create public health issues, you'll create complaints. And after that, instead of going above ground, I go underground, sewers and everything. So basically, my chance in engagement in water, and eventually, actually what I'm doing now is basically searching for new ideas to ensure the continual survival of Singapore. Basically, it's like what we did today, it only buys us time, because nothing is constant. Challenges will keep on changing. So you need to reinvent yourself to stay relevant. So that is very important for the country. You will understand later why we're doing that. Is it fun? No, because you always have to, in a way, get out of the comfort zone. You need to manage risk. And when you introduce any new ideas, you cannot, in Singapore context, we cannot afford a mistake. Because if they say, example, like one day we have a water quality problem, right? Maybe not for drinking, maybe for the industries. What's going to happen is that investors, confidence in us will be affected. We may not draw investment. So in Singapore, we are very dependent on investments even from France, from everywhere, to keep the country going, create jobs in Singapore. Okay, so that's what I'm talking about. So the title of my presentation, Vulnerability to Strength. If you read our water story, this is the point that we always say, vulnerability to strength. Vulnerability in the sense that should we accept our fate? Like what Prof. Vevi said, that we should basically be held ransom to water? Or should we keep on reinventing ourselves, such that in the end, to strength where we can control our destiny, our future? And then I add in the second point, perpetually need to innovate. Basically, bottom line is that even though we think that we more or less delivered in terms of enough water for ourselves, one of the biggest fear we have in Singapore is complacency. You're contented. Once you're contented, then I think that's where the comfort zone comes in, and that's where maybe things will start failing. So I think that's the point I want to try to drive at. And then, in the end, to do all these things, I think you hear from Prof. Yong that understanding, knowledge, of course, in my context, is in terms of everything related to water. So I don't confine myself to just pure engineering. Later on through my presentation, you realize that I need to go into the water science, chemistry, biology, even talking about public communication. I'm an introvert. But somehow it forced me through some projects to make me, in a way, to try to project myself to communicate. Because in some of the projects we're doing, we only one chance to make it work, which is actually new water, which later I'll explain. Okay, a bit about Singapore. This was Singapore. Standing pipes basically is that it's just one pipe is supplied to the whole village. And the supply is not every day. Sometimes it may be disrupted. Flooding. In fact, today also we had a bit of flooding because of heavy rain, right? But it's not the type widespread flooding that we had of last time. Should we accept this fate? Should we accept this? And basically become like maybe a good, curious tourist destination? Or should we try to level up and provide a better life for Singaporeans, which is like today? So we have 50 years of journey. That's where we are in Singapore. It doesn't happen overnight. Of course, water plays one important role, but it's the whole of government approach, not just on water. Water play a role in terms of the land use, because later on you understand why land use is very important. In terms of, not say, phasing out those pollutive industries, quarters and everything, house them, create jobs. Actually, by creating jobs, then in a way you increase your economic strength, or you save money. And with the money, you invest over time into infrastructure. You have money to build infrastructure. So even for us, when we say that Singapore is served 100% with modern sanitation, it took us at least 30 years since our independence. Constant investment. Can you imagine in 1965 when we got independent, we were poor. We were depending on World Bank for loans. And of course it came with the discipline, and through years of economic growth and we got money, so we start investing in our infrastructure. We can use the money for something that is quick wins. But this is a journey in terms of creating the right environment, we think, for Singapore and for Singaporeans. A bit about Singapore. We are only 720 square kilometers, and it cannot grow anymore. That's the limit for us. So imagine 6 million people in 720 square kilometers. We can give a cheap excuse, say, sorry, the land is a constraint, not enough water. No, we can't. If we do say that, Singapore will not get any investments and we will go downhill all the way. We are blessed with a lot of rain, 2.4 meters of rain. Then the question asked is that, hey, you got 2.4 meters of rain, it should be enough water in Singapore. Like example, like this morning was heavy rain, a lot of water. The problem for us is that we do not have land to store. We do not have land to store, conventional way. Our demand is 2 million cubic meters, 2 million cubic meters a day, and that is about mainly for domestic, it means household use, and for industries. So we do not have luxury of agriculture, all right, because it's an urban city, it's a city. No oil, we have nothing. We have no metals, no nothing, no gold, anything. So basically we have is people. So if we go by the conventional way of managing water, Singapore should be as dry as those countries in the Middle East. It should be as dry as Saudi Arabia. All right? So actually, if we accept that fate, you won't be having all these nice buildings and that. So we need to, in a way, imagine, create, and think differently. All right? And so, in a way, my presentation, it comes in two parts. The first part is basically solve the problem first. How do we overcome our land constraint? We know that by conventional way, the land will be the constraint. How do we overcome land? And then, after we solve the land, we must constantly be looking out for solutions because Singapore is not a country that is rich in resources. Everything is imported. So long-term wise, we once we solve the water problem, in a way we have to look at resources, energy, waste, and manpower. Okay, beyond our footprint. The first important thing that we did, in PUB, we are a believer in system. So actually, we are one of the very few utilities in the world that actually manage the whole water cycle. That means, in our context, there's no thing called wastewater, rainwater, seawater, everything is water. So question asked is that, how do we utilize it? So by managing it in the whole water loop, we actually, in a way, give us huge opportunity to try to think of different ways to manage our water. Of course, one of the key is recycled water, which we call new water, right? And basically, that's one of the key factor. Then we also convert seawater to fresh water. So this is the second strategy. So in a way, we closed the water in 2001, and the current PUB that we have today is basically a reorganization of the government agency so that we manage the water under one roof. Then with that closing of water loop, the way we manage water is based on three principles. Basically, collect every drop of water. That means collect every drop of water that falls in Singapore. Like today, it rained. We try our best to collect every drop of water and without causing any risk of flood. So in a way, it's a challenge also, how to balance between wanting the water and trying to get rid of the water to prevent flooding. Then, of course, we need to desalinate more water, right? It means basically the sea is the reservoir. So once you go to the sea is unlimited, all right? But, of course, later on, seawater is not free. The energy number is very high. And the key is basically how to reuse the water endlessly. So basically, if you were to able to capture fresh water, you're able to convert seawater to fresh water, how to keep it in the system as long as possible, all right? So that before you have to let go to the sea. So that is the key. So in Singapore, 2/3 of Singapore is water catchment area. So if you are, let's say in France, you have your catchment areas, which is far away from the city. It's supposed to be a pristine catchment area, all right? And basically is, then you take the water, draw the water from there, and go to the waterworks and goes into your household. In our situation, if you're being in the city area, the city center, the city center is a water catchment area. So this is one example. Our Mineral Reservoir is a reservoir in the city. So it's a go against convention. When we did this when we started looking into urban areas catchment about 30 years ago, people were saying that we are crazy because they think of all the negatives in terms of contaminants, pollutions, and everything. But if you put in the right policies, you put in the right controls, measures, pollution control, infrastructure, everything is possible. In fact, some of our conventional water engineers, they will tell you that, in fact, they acknowledged that some of the water from the urban area is actually more pristine than, or clearer or better than those from the forested area. Of course, we convert seawater to drinking water. So we have 3 plants, and you made out 2060. So by 2060, you meet 30% of our water needs. But of course, later on, you pay a price for it, energy, which later I'll explain. But the key to everything is actually reuse water endlessly. The ability is after the household industry use the water, the ability to collect back every drop of wastewater, clean it, and return back. So in a way, we are creating in a system the second drop, the third drop, the fourth drop, and we have many new water plants that is running. And maybe just share with you in terms of my personal journey in new water. Proving that it works is easy. But if you were to go back something like 15 years ago or 20 years ago, if you go and check the internet, where in US especially, where they talk about indirect potable use, it's all a psychological problem because it comes from wastewater. So it comes from wastewater, the issue is about, wow, if I drink the water, will I grow horns, will I have cancer, and everything, right? This is always the public perception. But the perception is real. The question is how to address it. So in the end, proving that I can get drinking water is easy. Communicating to the public, convincing them that the water is safe at all time, that is the difficult part. How do you break down engineering terms down to simple terms? For example, like how to explain to them, now go a bit technical, that the reverse osmosis pore size or holes is 0.00001 microns, that you were able to reject viruses, bacteria, and those dissolved salts. So in a way, we try to use animation. In a way, like example, like the tiny holes in the reverse osmosis membrane, if you magnify 100 million times, you'll be like a tennis balls. And water molecules, you magnify 100 million times, you'll be like tennis balls. Tennis balls will pass through a hole that is of tennis ball size. A virus is a truck. It's actually like a truck. So in a way, that is a way to try to relate to the public in terms of able to explain in technical jargon, break it down to a very simple way. It's not 100% precise, but it's 99% accurate. So why I say reuse is important, because it's the multiplying effect of recycling. If I'm able to, in a way, this slide shows, if I can recover 50% of the water, basically if I were to endlessly move the water in the system, right, I basically doubled my water footprint. If I were able to push to 75%, that means every 4 drops I can collect back 3 drops and return back, I can increase the system yield 4 times. So that is a key in us overcoming. So strangely, now the way we manage our water in Singapore is that we create virtual reservoir by moving water in the system. So if I were to say 75%, I got 4. That means basically I have 1 real reservoir, I have 3 virtual reservoirs by moving the water system. Because remember I told you earlier, the key is storage. But if I produce the water and someone can take it away, I don't need to store. The only storage I have is maybe 2-hour storage, more for supply reliability, and that's it. And the reservoir itself now became the backup, the raw water. So what I mean by that? So we have the definition of first drop. So if it's desalination, I add another, it's addition, I add another Singapore. Now, with Singapore and the desalination, if I recycle 50%, I create 4 Singapore, of which the green one is the desalinated footprint, and the white one is the effect of recycling at 50%. Right? So in a way, we must go beyond the size of Singapore. But of course, we solve the problem, but we pay a price. We pay a price in terms of energy, because desalination is not cheap. Energy number is very high. So later on, in my presentation, you'll see that we're trying to search for new ideas, try to even talking about comfort zone, overcome our comfort zone, how to manage risk, how to celebrate, management term, how to celebrate failures, everything, how do we, that it's okay to fail, right? But even if you fail, it's based on good science. Based on science, I think it's just either sometimes you're ahead of the game or you didn't anticipate certain things. So waste as a resource. So you don't view waste as waste, need to dispose of. Can we now look at some sort of way where through co-location, a waste can be a resource to somebody else? So in a way, finally, if we really, really need to dispose of the waste, instead of 100, let's say 100 tons of waste, maybe I need to dispose 5 tons of waste. The 95 tons is being reused. Manpower, Singapore, we have very low birth rate. It is below replacement. So, and it becomes very challenging for us, even as a government agency, to look for people to help us to run our plants. It's always an ongoing challenge. But of course, there are a lot of innovation in terms of Internet of Things, in terms of sensors, in terms of data analytics, everything. And hopefully that is something into the future that we are looking into. Okay, so going into the future, what is the consequences of us? If I business as usual, that means I accept, I'm complacent, I leave it to today, my water demand will be doubled. But the key is that when it doubled, 30% of the demand in the future, in 2060, will be met by desalination. And 55% will be met by new water. So both are a bit energy intensive compared to, it's nothing better than from the rain. The rain is literally the whole water cycle that's playing around. The sun is doing the work for you, right? The sun is doing the work, evaporation and everything, then condensation, then it fall down as rain. But in a way, we are doing something fast, so you need energy. So that's a price that we pay. So what is the consequences if a business as usual, complacent? Our energy will be 4 times, footprint will increase 4 times, although the demand doubled. So you thought, hey, doubled should be doubled, but it's 4 times, because the source of water is coming from desalination and new water. But more important also, the waste side. If we accept business as usual, our in terms of sludge demand will be doubled. So imagine that today I need 300,000 tons of sludge to manage. 2060, I have 600,000 tons of sludge. That means practically every day I have something like 2,000 tons of sludge to be disposed of. We have no agriculture, no land to spread, how to spread in this area. So we must look at solutions, right, in a way to help us overcome. So should we take waste as waste, need to be disposed, or maybe try to convert it into something useful? So strategy, key is technology. Technology is the enabler. So we talk about strategy, water, energy conservation, understood, and generation. It's a very simple term, simple, but how to get it? Waste as a resource I mentioned earlier. How to change behavior of households such that they treasure the water, right? In a way that water is precious. It's your job also to, in a way, to conserve it. And the other one point which I talk about is manpower. After we do everything, it still boils down to people. Because you can have wonderful ideas, you can have wonderful technologies, but in the end, make or break the technology is people, operators. People who are able to understand, to manage it, and run it properly. So one idea we have was desalination. So the numbers was very high. Today's technology is 3.5 kilowatt hour per cubic meter. That is the number. Should we accept it? Or start searching for ideas in a way to drive down the energy? So be very confident that we can bring down to 1.5. In fact, we've got some technologies that already are bringing it down to about 1.8 kilowatt hour per cubic meter, right? But our long-term goal is to go down to 1 kilowatt. So in a way, when I talk about 1, when I present this at international conference, all the professors will put out their hands and say, hey, Harry, you are going against the law of thermodynamics, you know? But in the end, is that sometimes you have a challenge goal, it's because, not because of anything else, is to, in a way, a goal that is very challenged, where you are never be satisfied. You're on a constant search for new ideas or technology. Whether eventually I got 1.1, 1.2, 1.3, it doesn't matter. It's better than 3.5. That is the key, all right? And so what we do is that we look long term. So sometimes when we run out of ideas, we go back to nature. So actually we are studying things like how did the mangrove swamps extract water. Mangrove swamps are in the estuary areas. There's seawater coming in. They can't be drinking salt water. We can't be drinking salt water. So how did the simple plant get water out of seawater? How did they desalinate the thing? So we're trying to get ideas from them. And next time in future, it has implications in terms of the medical side, because in terms of kidney dialysis and everything. So that, in a way, from the water side, it may also go into medical for once. We also study fish. How does fish extract water? Some in the sea, some in... Then how some fish, which can live between marine and freshwater environment, how did they switch, from marine to freshwater? There's a local fish called tilapia, which can switch between freshwater and seawater. So you had like, as though there are two systems, two trigger points. So you're trying to understand the thing. Wastewater, in future, wastewater will be a power generator. That means basically it should be more than enough energy in a wastewater treatment plant to run the wastewater plant. And then maybe if we get our technology right, process right, it may even help us to export some power. So these are the technology we're looking into. Recycling by industries, because nothing better than to ensure that industries themselves basically use the water wisely. So we are encouraging them to have the best practices and everything in a way so that to produce a product, they use minimal water or smallest water footprint. Even automatic meter reading, which I think in Paris, in Bordeaux, I think, they are really using it. So basically, the whole driver for that is changing behavior. We have pilot tested this, demonstrated this, and we strongly believe, but it's just simple changing of behavior using the automatic meter reading, which offers the consumer real-time data on their water consumption. We could save maybe about 60,000 to 100,000 cubic meter of water. Manpower, I told you earlier, low birth rate. So basically, we must do something about it. Okay, and then in the end also, in Singapore, every young person, he wants to level up. Everyone wants to be a graduate. So sometimes when you want to poly graduates is quite difficult. So anyway, a question asked is, how do we, in a way, redesign our work processes to accommodate the change in the profile of our workers, maybe in terms of level of technical understanding, competency, and basically, in the end, doing more with less. Basically, arm him with a lot of devices, a lot of sensors, so that in the end, he is able to do work better, more efficient, right? In a way, instead of 5 people down there, maybe it's 1 person and 4 virtual assistants running around. So we have whole of Singapore, we have armed ourselves with sensors. So basically, we're tracking water quality real time, partly as a service to the public in case of some issues. But the other one that is very important is security, water security. Marine barrage. So it seems that managing world water real time, this idea actually we learned from Bordeaux in France, where I think 5-10 years ago, there was a flood, something like that. So the question asked is that you go by the conventional way of widening the canals or rivers, it will cost you a few $1 billion. So by having all this technology in terms of real-time monitoring of moving the water in the system, it actually saved the city of Bordeaux a few $1 billion, if I'm not mistaken. So the question asked is that after they installed the system, is it proven that it really works? So I understand that in Bordeaux, there was 2 rainfall incidents that happened at the same time. So it was tested. So we are learning from France on some things. This is a project that is from a failure in the sense that the science, the logic is that if I can produce electron immediately from wastewater treatment plant, it's the most efficient. But we made one mistake. We forgot about the footprint, because the resistance is very high, so the footprint has to be very big. But when we went to the lab, we saw that, actually the fuel cells is a very miniature, small ones. The question asked is that, can we use it as a sensor in terms of source control? Because remember earlier I told you about water reuse. So one of the water reuse thing is that the water may come from industries, so the source control is very important. And we have been searching around for good sensors that tell us there's someone illegally discharging something. You will trigger alarm, you will immediately collect a sample automatically, and we analyze the data, you can prosecute. Instead of today, it's a cat and mouse game. You open manholes, you can discharge at night, you can't catch the person. So now with this thing installed in the factory, it's 24/7. So he got to behave himself, right? That's the key. Then, as I said earlier, the future challenges is that manpower. So we need to pick up new skill. The blue ones are the traditional skills that we have that bring us to today. But looking into the future, I think some of the things that you do masters in terms of the thing is there. Artificial intelligence, data analytics, machine learning, wireless communication, data communications, these are all very important. These are all the new skills that in way PUB we need to reinvent ourselves. We need to develop new capabilities so that in the end, we can meet the future challenges. So these are very exciting time. In fact, some of these skills are lacking in Singapore, and we are searching around for people to help us to develop all these capabilities. And then with that, thank you very much.
Thank you, Harry. Thank you very much for the presentation. Very relevant to how we find access, the environment, the question of academic sustainability, the question of the people, and so on. We have just a few minutes for 1 or 2 questions. If someone wants to ask a question to Harry, to start about. If someone wants to try to do. to Harry. Yes, Joyce?
Hello, and thank you for your presentation. So, since we were talking about creativity, do you think that the lack of resources was actually a chance for Singapore to become creative? I mean, like, if you didn't have this lack of resource, will you be Singapore today? Will Singapore be Singapore?
No, in a way, you're right. It's the lack of resources. Because, in a way, if you look at Singapore itself, right, we are cornered. Cornered in the sense of being in a tight spot. And we need to get out of the corner. So it's either you find ways to get out of the corner, think of different way. Should I go vertically? Should I go not to get out of the thing? So in a way, because of who we are, that in a way it is an ongoing challenge. That today best practices that you see in the textbooks, it's not good enough for us. And remember, I told you earlier, if you go look at textbooks, how you manage water supply? Oh, you have a reservoir, you store the water, then you have waterworks and then supply the water, the rain comes and you fill up, you have a catchment area. But we don't have that. We don't have catchment area. Unless you say you make the whole Singapore a reservoir, right? Which is impossible. So we try what we think we push to the limit of everything without risking in terms of water quality. But bottom line is that because of lack of resources, even land, energy, manpower, we need to always reinvent ourselves. So today I got something, I'm very happy, I implemented it, like New Water. New Water was implemented more than, it's already 15 years. So New Water is already history. We need to for new things to make ourselves relevant and build up the capacity to ensure the long-term existence of Singapore.
Hello.
Yeah.
Thank you for your talk. Do you see any limits to how far progress into the water industry? Like, are there any limits that someday will be unable to give water to, for example, like 10 million Singaporeans? We know that's the limit.
We work on no limits. We have two. We don't know what is the planning number, right? So basically, is you just work to the, you just work to the, I put away, to whatever the buffer you can build, because the country needs buffer. You cannot work on very tight numbers. So basically, is that if I'm ahead of the game where I develop too much water, it's fine. That means you can draw on it. It's like it's a bank account that you can draw on as you just building up your savings. And then you come to bad time, then you start drawing the thing, but you got enough savings to draw down. So we work on the basis that now, 10 years, 20 years, 30 years, 50 years, question always asked, it's always been asked, can we always increase our water footprint more and more? So when I told you that we can push to be able to collect back 75% of the water, now if I push to 90%, it's 10 times. It's 10 times. So these are the things. So it's buying insurance, right? So that when things come, I just pull out from a drawer, I just do it. Okay?
Thank you for your very interesting talk. I was wondering about the energy mix in Singapore. You talked a lot about the energy footprint of desalination. Where do you get your energy from? Does Singapore have gas plants or lots of renewable energies? Or?
We have the largest oil refinery industries, but all the oil is outside being processed in Singapore. So we have no oil field, unless we go something horizontal.
Good, Mike.
Hello, Mr. Seah. Thank you for your speech, and I have a question. Because when we talk about innovation, we're talking about to change the world to a better world. So can I ask, have you applied your ideas to other corners of the world? Like, see, you talk about Saudi Arabia. So have you received other countries' expert groups to show them around, tell them how you resolve this water scarcity problems?
No, we do share. We do share how we do it in Singapore. But we are very mindful that Singapore is very different from other countries. They have their own set of challenges. So what our most best we can do is communicate in all honesty. How do we're sharing information as much as possible, how we manage water in Singapore. And it's for them to take what is relevant to them. Not everything in Singapore is relevant because we are city-state, all right? So, but I'm sure maybe not 100 ideas there that Singapore is doing is relevant, maybe 30, 40 of them. Likewise, when we went to US, we just only, in US is a big country. So the consideration is a bit different, but there's some good ideas that is applicable in Singapore. So we just take up whatever is relevant and apply in Singapore. Likewise, it's the other way around, all right? So we do share, all right? But one thing is that, so in terms of water story, I was trying to share with Professor Pevi is that, so people ask, hey, why don't you go out? Why don't you get help? Why don't you go and help those countries? Why don't you help, let's say, go to China and try to do something? But China is huge. It's huge. Each city is as big as Singapore. So can you imagine, we don't even have enough people to even want to help China. Of course, in just simple technical terms, So, and mind you, when we go into it, it's a journey. It doesn't, let's say if I got any idea we have, it doesn't happen overnight. It takes 30 years. Get infrastructure, infrastructure takes time, right? So basically is that the best we can do is share what we have, what we understand, share our knowledge. Is for individual countries, whether in China, India, wherever it is, using own local expertise to pull up whatever thing is relevant for them. I think that's the most sustainable way. We don't have enough people in Singapore to help. We can share.
Another question.
Thank you for your session spotlight. And I have a brief question regarding imported water.
Yes.
So what countries do you import water from?
Malaysia? Malaysia?
Malaysia only?
Yeah.
And speaking of the volume of the imported water, what would it be? And what are you planning to be, to have, let's say, the current situation and what you see in several years? What share of imported water would be in Singapore in 2068?
Okay, maybe I answer you the other way around. We had 2 agreements with Malaysia. 2 agreements. One of the agreement lapses in 2011. 2011 passed already, 6 years ago. And the other one, which is the second agreement, is 2061. 2061. That means it's another 40 over years. The agreement that lapses in 2011, we didn't renew the agreement. We had developed enough resources on our own to substitute or to replace the agreement. Of course, 40 years down the road, things may change. We love to continue to take water from Malaysia, but I suppose they have their own challenges, right? So I suppose, in a way, if you look at the first agreement, we're quite confident that we can easily replace. So That's why I noticed that 2060 is a nice year.
Yes. Good afternoon. Thank you very much. Very
This is my football friend.
Yes, I'm very proud Singaporean. But I have a question for you, which even as a Singaporean I don't know. As a pioneering leader in this area, for helping us have water for so long, were there occasions where some of the technologies that you've applied did not work, or rather it failed? Perhaps you can share with the class the kind of learnings that came with it that was even more important. Have you been successful in the first time around? Thanks.
I prefer the turn the other way around. You talk about failure, which I thought about is the microwave fuel cells that we did, that it failed. So I prefer the turn the other way around in terms of like new water. You must go back to year 2000. Year 2000, we have zero experience in membrane, right? So the prof talked about comfort zone. Everybody are so comfortable with the, very comfortable with what I call it, comfortable with the way we manage our water, get water supply. Hey, Malaysia still got 40 over years to worry about it. Don't worry anymore, right? These are the things that is going on. So, membrane is new. Membrane is new. The whole PUB, nobody had experienced a new thing. So everybody, it's easy. One thing you learn, one thing you all learn is that the only way you don't make mistake is express concern. It's easy to express concern. Because express concern, nothing will go wrong. You will never make mistakes. If you think turn out true, I contribute. If the thing doesn't work, I told you, right? So it works both ways. It's a negative energy. So in a way, actually part of my job is to create positive energy. Basically, it's that look at things in a way that people always accuse me, Harry, you're very optimistic. I have to be optimistic. If I'm pessimistic, nothing will, I'll think all the negative things, why it cannot work. So in a way, like new water example, we actually, as an engineer, my job is not to apply the theory. Actually, I simplify it. I simplified the operation. So by simplifying the operation, it's like actually, I got the professor a bit irritated with me when I told them that I apply my A-level chemistry, my high school chemistry, in running my new water plant. It's like water chemistry, I told them. It's just that if you take as much water out of the system, the salt will precipitate. You learn in science, right? Which they call it scaling. It's scaling, right? So basically, don't overcomplicate things. If things are simple, just apply simply, right? And if you see a water coming in not so good, you just basically polish it. So actually, he asked me, the biggest challenge is not about failing. I think we created the platform for a lot, over time, over the last 10 years, allowing people to fail. And in fact, now I got our operation people, which is the hardest people to convince, to in a way to take the lead in the project, and the project doesn't work, we understand why it doesn't work, and full stop, and learn from it, right? That's modern, right? But in the end, the science must be right, because in the end, the money that I spend, I have a luxury of budget of about $20 million a year to just spend on trying things. But I can have a license to do everything, but that's public fund. So I need to do nice technical assessment, right, based on science, engineering, and then if applying the most optimistic scenario, how does the number stack up? If based on the most optimistic scenario and the number doesn't stack up, we kill the project, or kill the idea. If based on the most optimistic number and you say, hey, there's some room for, there's a potential there, then we put money into it, right? You cannot start with start factor of safety. Okay? So.
Thank you very much, Harry. Thank you. That was very great, inspiring
opening lecture. That was an honor to receive you for Imagination Week today. Thank you again.
Okay.
Thank you. Thank you very much. Thank you. I would like to